If cutting sugar improves almost every chronic disease, shouldn't we be asking why? Is it just coincidence? Or is something upstream actually driving all of this? Because if what we've explored in this series is even partially correct, then this isn't really about sugar. It's about a pathway. And by the end of this video, I'm going to show you what that pathway is and what you can actually do about it now. Let's compress the model. Across chronic disease, regardless of the label, there is a consistent early pattern. Before organs fail, before symptoms become obvious, cells begin to lose stable energy. Not calories, not body fat, but cellular energy, the ability to produce and sustain ATP. And that's what's striking about fructose metabolism. It does something very specific. Through an enzyme called fructokinase, it rapidly lowers cellular energy. ATP drops, uric acid rises, and mitochondria shift away from high output energy production. It doesn't damage the cell first, it suppresses it first. And once you see that, a lot starts to line up. The biochemistry supports it. The historical rise in sugar tracks right along with chronic disease. Nature uses fructose deliberately to slow metabolism and store energy. And across major disease categories, liver, cardiovascular, metabolic, neurological, you see the same underlying constraint: low cellular energy. So even if fructose isn't the only cause, it's clearly a convergent cause, a pathway that reliably creates the exact state that we keep seeing downstream. So what do we do about it? Most people stop at reduced sugar, and yes, that helps, but it's incomplete because fructose isn't just something you eat. Your body can make it. High glucose can be converted into fructose. Dehydration can push that pathway. High salt intake can push that pathway. Alcohol pushes that pathway. Stress conditions push the pathway. So that signal can stay active even when your diet seems to look clean. And that's where the frustration comes from. It's not that people aren't trying. They're trying a lot of those things, but it's that they're only targeting one input in a system that has many. And that's where this model actually becomes a bit more intuitive. This isn't a broken response. It's an elegant one. Your body has a built-in survival program designed to activate anytime conditions are unstable, whether that happens to be excess or scarcity. And when that happens, it shifts towards conserving energy, storing fuel, and protecting itself, which means that the problem isn't that your body's failing you. It's that it's doing exactly what it was designed to do, just too often. It also explains why so many different inputs feed the same pathway. Diet, hydration, alcohol, stress, these are all signals of environmental pressure. It even explains taste, sweetness, salt, rewarding foods that are signals historically that meant opportunity. And so your brain nudges you towards activating the pathway when it actually matters. In a world of scarcity, that's brilliant. In a world of constant access, we see it become a problem. So if the issue is activation, the question becomes, where do you intervene? And this is where things become very clear. The real switch isn't fructose, it's fructokinase. This is the enzymatic step where the ATP drop begins. This is where the cascade starts. This is where the signal becomes real and starts influencing us. We have a very powerful experiment in nature. People with essential fructosuria lack functional fructokinase. They still consume fructose, but they don't metabolize it normally. And importantly, they don't develop the same chronic disease patterns. This tells us two things. It tells us that the pathway is not required for survival. And it tells us that it's directly tied to the outcomes that we're trying to avoid. Then you look at animal research. When fructokinase is blocked, many features of metabolic disease simply don't develop. Fat accumulation drops, organ damage drops, metabolic dysfunction improves. And what makes this even more compelling is that this happens even when glucose remains high, which suggests that a meaningful portion of what we blame on glucose might actually be mediated through fructose metabolism. The glucose is becoming fructose. And now we're seeing this move into humans. Pharmaceutical inhibition of fructokinase in clinical trials is showing reductions in liver fat, improvements in metabolic markers, and signals of organ recovery. So at this point, it's not just a hypothesis, it's a validated target. Now think about all that we've been doing to try to solve this over the decades. Reduce sugar, avoid carbs, drink more water, limit alcohol. All good advice. But all of it is trying to control the same thing indirectly: fructose metabolism. The problem is that there's too many inputs. Diet, hydration, stress, alcohol, the metabolic state. Trying to control all of them is extremely difficult. That might answer why restrictive diets fail so often. It's like trying to manage a soundboard with 20 different sliders all feeding into the same output. So, instead of chasing every input, you target the amplifier. So if the target is clear, fructokinase, the next question becomes very practical. Is there a way to influence this pathway directly? That's where luteolin comes in, not as some random supplement, but as a direct extension of this model. Luteolin is a naturally occurring flavonoid found in many plants that humans have consumed for a long time. What makes it interesting is what it does. Mechanistically, there's evidence that luteolin can inhibit fructokinase activity, meaning it interferes with the exact step where fructose begins lowering cellular energy. Now, when you look at the broader literature on luteolin, you see something unusual. It shows up across metabolic health, inflammation, cardiovascular function, liver, brain, even cancer-related pathways. And at first, that sounds scattered, like it does everything. But through this model, it might be unified. Because if you reduce activation of a pathway that suppresses cellular energy, you should expect broad systemic effects, because you're acting upstream. You're preventing that fragility. Then you add the human layer. Ingredient-level trials show improvement in liver fat, insulin resistance, and lipid profiles. Those pharmaceutical trials targeting fructokinase show very similar directional outcomes to what we see in luteolin. Different compounds, different approaches, but the same pathway and similar results, and that parallel matters. Beyond the literature, we're now starting to see consistent patterns in the real world: more stable energy, reduced cravings, easier weight regulation, improvements in markers that people are tracking. That does not replace clinical trials. But when it lines up with the mechanism and controlled data, it starts to become hard to ignore. So while this is not definitive proof, it is a strong convergence of evidence, which makes luteolin a very reasonable tool to experiment with, especially when the goal is not to override the system, but to just stop overactivating it. So then this stops being about discipline, and it starts being about control. Not controlling every single input, but controlling the system itself. Because if this model is even partially right, then chronic disease is not just a collection of separate problems, it's a state. And fructose metabolism is one of the most reliable ways to create that state. So the goal isn't to eliminate fructose. The goal is to stop the signal from being constantly active, because when that signal drops, cells don't need to be forced back into health. They move there on their own.